just a test. This is just like do the integral and see what happens, right? Just like actually run the integral. So why is this in this section? What type of integral is this going to be?
Improper.
Improper, right, exactly. Why? Why is this an improper integral?
Because 0 can't be kept.
Because 0? I heard, yeah, 0 causes a problem. What specifically about 0? Yeah. Yeah?
The function goes to infinity at one bounds.
Okay, so if we want to actually do this out here, we change it to the limit as what? A goes to 0 from the, right? A to 6 of w to the negative 2 dw. Now we take the what? Yeah, so what's the integral going to be? W to the?
From
A to 6.
And it's the limit as a goes to 0 from the? Now you just have to be careful with the negative signs, right? So what do you end up with? You end up with, let's plug in 6, negative 1 over 6 minus negative 1 over what? A. And it's the limit as a goes to 0 from the right. So you end up with the limit as a goes to 0 from the right of negative 1/6 plus 1 over what? A. And what's that going to be equal to? What happens? This gets infinitely small and positive, so what happens? What happens to this? This goes to infinity, right? So this whole thing goes to positive infinity because you're just subtracting negative 1/6. So does this converge or diverge? This diverges, yes.
Is there a reason for us to use W?
Gave you that right there. If you try to do this, end up with negative w to the negative 1 from what? 0 to 6. So what's that going to be? Negative 1 over 6 minus what? Negative 1 over? It's undefined. You'll run into a wall. You won't be able to plug in your limits. You're going like 4 to infinity of 3 over alpha d alpha plus 4 to infinity of what? Sine theta over theta d theta, right?
Yeah, and the first one obviously diverge.
Does this? So what happens? Yeah. So this one, right? So you have to be real careful here. So this is 3 times 4 to infinity of 1 over theta d alpha, and this one definitely what? Diverges, right? Now you just have to be really careful because you can't just ignore the other part. It's yeah. Go ahead. What are we trying to solve for now? Y. It tells you you're solving for y right there. So how do we go about solving for y? This is in log form. We turn it into e to the kt plus d equals y minus a. Well, here's the thing. E to the kt is always what? This is always positive. So we therefore know it's e to the kt plus d is equal to y minus a. So y is equal to?
E to the kt plus d.
Exactly. Plus d. Nice.
And then can we take out the d?
Yeah, so the path you would take. So for example, let's say I picked right here. What's going to happen? Looks like it's going to go like up like that and maybe down a little bit like that. What happens if I pick this one right here? It kind of looks like this. Woo! Something like that. But the point is, do those paths change depending on what initial condition I pick? Yeah, if I pick this one, it kind of looks like it goes like this. What you're looking at is the entire set of all of the integrals of some differential equation. All of them, all of them, all of them, all of them, all of them. Okay, so this is a really common question, and it seems like it's harder than it is. Look at y equals x. What should you see? Vertical tangent lines, right? So which one is that? Looks like it's B, right? So we can immediately go to B, because if you go to these, what did the slope be? These are all 0, right? And here they're changing. But here they're all vertical, so it really looks like B. Is there another way to analyze it? Absolutely. So for example, how about, what's another point we could test in there? What? 3 comma 2? You want to do 3, 2? So if you do 3 comma 2, you should see something really steep, right?
And then,
you should see something really steep and positive. 3, 2, 3 minus 2, so it should have a slope of 5, right? So if you do 3, like, the problem here is you don't really know where 3, 2 is, right? Because there's no scale. You see what I mean? But you can kind of go over and up. Are these steep right here? No, but they're really steep here. Are they? Oh, they're kind of steep here. So that would eliminate this one, but it might not eliminate these two. So what you can do is you can test certain points or certain subsets of points. How about when, are any others, y equals negative x? What happens when y equals negative x?
It's 0.
The slope is 0. When y equals negative x, the slope is 0. So you look at that, and you can draw these y equals negative x, slope isn't 0, but what about here? Oh, and what about this one? Yeah, if you do y equals negative x, you see slope of 0, slope is infinite, or however you want to say it, vertical lines. So do it by process of elimination. Okay, so there's a certain type. So if I started out, let's say the initial was like right here, what's this thing gonna do? It looks like it goes up. Oh, kind of goes up like this. What happens if it starts up here? It goes down like this. What am I modeling? Anybody want to guess what I'm modeling here? Well, bell curve has more of a, goes up on both sides. This just goes up towards that yellow. Anybody factor out of, what could I factor out of the right-hand side if I wanted to? I could factor out a p. I could also factor out a 10 if I wanted to. If I factor out a 10, what does this become? dp dt is equal to what?
P times 1 minus.
Yeah, it turns into 1 times p times 1 minus what?
P over 10.
P over 10, right? Correct, if I factored out a 10? You will generally see it written this way, where you always want it to be 1 right there. And therefore, where's the carrying capacity now? The denominator underneath the p. So the carrying capacity is right there. But this is the general form you generally see for logistic curves. Logistic curves, noticed quite aptly, Josh, is this. This 1.1, this 1.21 right here, where did that come from? Where did that 1.21 come from? 1.1 plus 0.11. Correct. So there are going to be ways to have shortcuts where if you uncompress this, you can make it go faster. I'll leave it like that, okay? You can make it go faster. Variables, so what do you end up with here?
dy divided by y and x dx.
Negative x dx, like this? Is that correct? Yeah, that looks correct. Nice, so what do we do to both sides? Integrate both sides. So what do we end up with? 1/2 y squared is equal to?
Negative 1/2 x squared.
Plus some constant, right? So what do we get? Y squared is equal to?
Negative x squared.
Plus 2 times a constant, but sure, whatever, right? So what does y equal?
Square root of negative x squared plus c, which is
2c, like that? Okay, so we could use that. So what do we end up with? We end up with this curve right here. How do we know it goes through that curve right there? What does it tell you? We want to anchor it to that point right there. So we need to solve for what? C, right? What point does it go through?
0, 1,
0, 1. So what do we plug in here? We plug in 1 is equal to the square root of?
2c.
0 squared plus 2c. So 1 is equal to the square root of?
2c.
So c is equal to? 1/2. Is that correct? Okay, so we could take that, we could plug it back in, and then we end up with y is equal to negative x squared plus 1 to the?
Negative,
To the 1/2, right? Correct? So we have this right here.